So students, our today's topic is perspective projection. Yesterday we had discussed about projection, and we had discussed there are two types of projection. One is a parallel projection, another one is a perspective projection. And we had discussed that in perspective projection the realistic image of an object can be obtained. The 3D object can be obtained on the view plane, 2D view plane. So in perspective projection, the viewing coordinate positions are transformed to the view plane or projection plane along the line that converge to a point. That point is called projection reference point. Here this point is projection reference point, and this is the object that we want to display, and this is a 2D view plane where we have to display that object. This is in perspective projection. Perspective projection, the major definition in the perspective projection, that is the vanishing point. This is one of the important characteristic of perspective projection. So when a three-dimensional object is projected on a view plane using perspective projection, then the parallel lines of the object parallel to the view plane, that is parallel lines of the object perpendicular to the view plane normal, will be projected as a parallel line on the view plane. However, if lines are not parallel to the view plane, that is they are not perpendicular to the view plane normal, they are projected into converging line that appear to meet at some source. That point where these lines appear to meet at a source, that point is called vanishing point. This is just like in comparison to the visual illusion that rail tracks appears to meet at a point on a horizon. That is called vanishing point. And one point perspective projection, when view plane intersect one principal axis, that is called one point perspective projection. In this type of perspective projection is called one type perspective projection. The another one is 2-point perspective projection, when view plane intersects two of the principal axes and two principal vanishing points are obtained. In 3-point perspective projection, the view plane intersect all the three principal axes, then three principal points are vanishing points are obtained. That is called 3-point perspective projection. So now let's discuss the mathematical description of the perspective projection. Before discussing the mathematical description of the perspective projection, I forgot to discuss one more important characteristics of perspective projection, that is perspective foreshortening. Perspective foreshortening, this is another characteristics of projection, that is an illusion that object appears smaller as their distance from the projection reference point increases. That is, projection of the distant objects are smaller than the projection of object of same size but closer to the projection reference point. Suppose two airplanes of same size are flying, and a human being that is looking at that two airplanes, but they both are flying at different, at the one is flying at the smaller distance than another one is flying at the larger distance. However, the size of the both is same. The human being who is looking at those two aeroplanes, his eyes is the projection reference point. So the one that is flying near to the projection reference point appears to be larger in size as compared to that one is away from the projection reference point. This is just a real life example of the projection reference point. Sorry, not projection reference point, but perspective foreshortening. Now let's discuss the mathematical description of perspective projection. Suppose we are having a point P, X, Y, Z. X, Y, Z are the coordinates of that point. and this is our view plane. This is projection reference point. When this object P is projected at the view plane with coordinates x dash, y z and z dash, the here we draw the projection line from P toward the view plane that meet z v axis at the projection reference point. That point is C here. The point px dash y dash z dash at which the projection line intersect the view plane forms the projected image of the object of the point. The parametric equations for this perspective projection can be written as x dash is equal to x dash is equal to x minus xu, y dash is equal to y minus yu, z dash is equal to z minus z plus zprp into u. These three equations, we can say these are the parametric equation for any perspective projection line that can be written as like this. Here the value of u varies from 0 to 1, so we can write 0 is less than or equal to u is less than or equal to 1. So what I mean to say here is, suppose u is 0. Suppose u is 0. So if u is 0, then we can say that x dash is equal to x, y dash is equal to y, and z dash is equal to z. And this object point is xyz itself. When u is 1, I have told that the value of u lies between 0 and 1. When u is 0, that means the object is at the same location, that is at xyz itself. Now when u is equal to 1, then what happens? X dash is equal to x dash is equal to 0, that is x minus xu. U is 1, x minus x is 0. In the same way, y dash is equal to 0 and z dash is equal to, this is z minus z plus zprp into u. So z, when we multiply this term by 1, it will become z minus z0, and the value of z dash would be minus zprp. And here you can observe one thing: when u is equal to 1, then we can say it is projection reference point. So we have to display the object anywhere between these two things, anywhere between the exact location of the object and the projection reference point. When u is 0, then object is at its same location. When z is equal to 1, that it is the projection reference point. So our view plane is set between where exactly is the object and in between, somewhere else between the exact location of the object and the projection reference point. So we can say the value of u lies between 0 and 1. Suppose the value of z dash is at this zvp, because we have this view plane, and the view plane, the coordinate of z is minus zvp. So we have to write it as z, and this is y, that is z and y. Suppose, consider on the view plane what happens, z dash is equal to minus z vp. So we can say that z dash is equal to z minus z plus zprp, that is a parametric equation we just discussed, into u. So here you can write z dash is equal to minus zvp is equal to z minus z plus zprp into u. Next it can be written as z plus zvp, moving this zvp to this side, and that is, another one is z plus zprp into u. So the value of u that is obtained according to our view plane is u is equal to z plus zvp divided by z plus zprp. Putting this value of z, putting this value of z into those three parametric equation, we'll get x dash is equal to x minus x, sorry, so x dash is equal to x minus x multiply by, that was xu, so x multiply by z plus zvp divided by z plus zprp, that is the value of u we just discussed. So at this equation will become, after solving, x dash is equal to x multiply by zprp minus zvp divided by z plus zprp. In the similar way, we can say y dash is equal to y multiply by zprp minus zvp divided by z plus zprp, and the value of z dash will be minus zvp that we have discussed initially. So the above equations are the general transformation equations for the perspective projection. So now we can consider the different cases for the same. One of the special cases when the view plane is at the origin. If view plane is at the origin, then we have to consider the value of z dash as 0. In that case, the view plane, so we have to compute these values according to that case. The another special case can be if the view plane is at the origin of the coordinate system perpendicular to the viewing plane z-axis. So another special case can be if the projection reference point is at the origin of the view plane. In this case, in this way we can write the different mathematical forms of for these perspective projection as according to their view plane. Now let's discuss what are the advantages of the perspective projection. Object further from the viewer are projected smaller than the same sized object closer to the viewer. That it means the another one is it looks realistic. That first advantage we had already discussed, the perspective for shortening. Equal distances along a line not projected into the equal distances, that is non-uniform for shortening. Angles preserved only in planes parallel to the projection plane. So it's more difficult to construct by hand than the parallel projection. In parallel projection, the exact measurement can be retained, however the realistic image is not obtained. In this case, the exact proportional of the size is not retained, however the image is realistic. So thank you.